Hello, welcome to this video on reviewing synthesis report. In this video, you will learn how to generate and open an optimization report for your design, and how to review such report, such as the summary page, loop analysis, bottleneck viewer, area estimates, and the system viewer. Let's open an example report. Okay, here is the same code sample from the emulation demo. We have already run CMake to generate build artifacts. Now I'm going to demonstrate how to build and open the optimization report for this design. Same as emulation, we will use Make to build the early image and the report for the design. On Windows platform, we can use mmake instead. A .prj folder will appear in your build directory, and inside you can locate the report file under the reports subfolder. You can open the HTML report with a regular web browser. Upon opening the report, you will arrive at the summary page. You will find the primary information in the center of the page, an overview on the left, a source code viewer on the right, and a details panel on the bottom. The rest of the report will follow a similar layout. At the top, you can see the compile info section, which include the name of the project, the device or board target, the versions of SYCL and Quartus used, and when the reports were generated. Next, you can view the kernels that make up your design, and some brief information about them. The clock frequency section shows the compiler estimated Fmax and the actual Fmax achieved by the Quartus fitter, and how they compare to the target frequency. The resource utilization summaries shows a brief overview of the resource estimation of the kernels in your design. Note that the more accurate Quartus fitter area and performance estimates in these sections will only be populated after running a Quartus place and route. The loop analysis report contains information about each loop in your design and can help you examine whether the compiler can maximize your kernel's throughput. The report shows some key performance metrics for each loop, such as whether the loop is pipelined, the II, and the scheduled Fmax. Generally, it is desirable to have an II of 1 and an Fmax which reaches the target frequency. For example, we see that the compiler scheduled the for loop on line 21 with an II of 86. Click on it will show more detail of this loop. And this will bring us to the bottlenecks viewer. The bottlenecks viewer can be accessed via either the loop analysis or schedule viewers. It lists all the loops that result in a throughput bottleneck for the currently selected system. For example, clicking on the loop on line 21, we see that the increased II was due to a memory dependency. The system viewer shows an abstracted netlist of your design in an interactive hierarchical graph. The block view provides a more granular system view of the kernel. The cluster view provides more granular graph view of the kernel. In the graph, critical paths that are affecting your performance will be highlighted in red. You can click on each node to see more information in the details panel.